we worked on building an online interactive learning platform, which could be used by many products across Ticketmaster. So we are interested in improving performance by using online interactive learning in the following scenario. Where a user comes to Ticketmaster, then we choose information to present, then a user reacts to the action we took. So the goal is to interactively choose content and use online feedback to improve the model continuously for better future content. So this is a very general application scenario. For example, in search, a user comes to Ticketmaster with a query, then we choose query result and the user reacts. In search engine marketing, actually we have artists coming to Ticketmaster, then we choose how much money we bid for this artist on Google, then the market reacts. So the platform uses contextual bandit algorithm to improve performance in such application scenarios. Contextual bandit online learns a better model by taking consideration of users' feedback while doing exploitation and exploration. So exploitation means we take advantage of what we already know, and exploration means we occasionally try something we are not certain of, which might be a better choice in the future. This is necessary because we are facing an ever-changing world. For example, our old recommendation strategy only uses exploitation, which might provide us suboptimal solution. For example, if we have two artists with ground truth popularity that looks like these two lines, if we only use exploitation, at the beginning of the time, we observe that the blue line is better, so we recommend it to the users. Then the user only sees the blue artist and interacts with him or her. And the user never got a chance to interact with the red artist. So this area is what we get by the existing strategy. However, by doing exploration, at the beginning, we occasionally try the red line, but for most of the time we use blue line, so we don't lose much here. Later, we observe that the red line is actually better. Although we occasionally try the blue line, we recommend the red artist for most of the time, and this is what we can get. So it's pretty intuitive that the new strategy adapts to the world with uncertainty. So what we build during the hackathon, and actually what we are continuously building, is this exploration engine, which has been applied to our existing recommendation system. So here's an example. This is the endpoint of the old recommendation system, which recommends artists in the Los Angeles market. So we can see that we first recommend Long Beach Ballet, which has a high score. The second one is Dirty Dancing. The last one is Legend of Zelda. So if we refresh, the first they keep the same because we are only doing exploitation by using what we already know, which is static knowledge. So the new strategy specifies an exploration factor in the endpoint. We can see that by using this strategy, we still keep the best things we know, but interestingly, at the end of the list, we have Fall Out Boy and Strange Love. Then if we refresh, we still have Long Beach Ballet on the top, but this change. So this strategy allows exploration of new artists that we never show to the user. And this behavior actually encourages user to click to refresh our website and do discovery. We actually show that the algorithm will, with a very high probability, will keep the best candidates in the list, but does exploration here. By running only 500 iterations, we were able to get over 97% coverage over all artists, comparing to less than 4% coverage using the existing strategy. We also, to show how general the platform is, we applied it to a new module called Happening Soon, which basically recommends events happening in the next several days. We did some testing by manually select candidates to show and observed easy lift in our income. So we applied this platform, this strategy to Happening Soon. So in the endpoint, if we specify max days equals 10, then we will get only events happening in the next 10 days. And as you can see, the candidates at the bottom just keep changing. So for the future and what we are currently working on is we want to introduce more sophisticated context, which allows multiple application and personalization. We want to build a general platform for all Ticketmaster products. So different teams just define their context, define their cost of taking different actions, and the platform will continuously learn a better model online that makes better decisions continuously. So this platform should have positive impact on search, what to show in Spotlight, what to show for advertisement, what to show for recommendation, and any new module you can think of. Also, is expected to improve performance in search engine marketing. Thank you.